Hey guys, we're looking at your Unit 2 study guide for Integrated Math 2B. Just a reminder, if you're working in this study guide, it's only if you chose to complete the exam. There were two options again for your TGA, Teacher Graded Assessment. There's the exam, which you'll be working on the study guide. The other alternative was a project that is in Canvas. So if you chose to not do the project, you wanted to do the exam like we normally do in class, this is our study guide video for you. All right, so looking through our study guide, on slide 2, I've got a key helping you find out where the slides are, where to go. We're going to start with 2.1. There's always, again, a title slide for each topic. So 2.1, we talked about circumference and arc length. All right. The questions also in the study guide are organized based on the questions that you'll see on your exam. So the number of questions that are here are the same number that you'll see. And I believe there are 5 questions. I can confirm 5 questions at this point of me making the video. There are 5 questions. Yep, 5 questions. So each of the study guide is always organized based on that question. So if you're using this during the exam, you need, to check your answer, you're checking, looking at a sample. That way it's kind of easier to navigate while you're in the exam. All right, so your first question is going to look something like this. You'll have a card sort. I will point out, so these pictures are all like in this study guide, they're like carnival themed, so like treats. So I will help us out. This snow cone, right? That's a cone. This caramel apple is like the closest thing I could find to a sphere. So that's a sphere. And I will help us out here that the popcorn bucket is the closest thing I could find to a cylinder, even though it's not exactly like a perfect cylinder, right? Or like a can would be a cylinder. Rectangular prism in this example is magic bars. And then you're looking through your Engagely notes and matching the volume formulas for a sphere, a cone, a cylinder, and a rectangular prism. In this study guide, the answers are there. They should be linked. I will have to double check why it's not showing on my end, but by the time you watch this, hopefully it will be visible for you. Maybe I have to like sync them all to something. Let's see. There should be a check answer. Okay, on your end, when you take this, it will be there, so you can click check and then see if you got it right. Okay. Slide 5. So this is another variation for question 1 that you might see on your exam, which is talking about arc length. So a circle has a radius of 3. An arc in this circle has a central angle of 340 degrees. What is the length of the arc? And leave your answers in terms of pi. So just a reminder too, again, for our study guide. So for each question, there's, except question 1, where there's 3 different variations it could be, there's always a question where I'm going to walk you through it in a video. And then the part 2 question, again, is always a bonus. This is like for you to try it on your own. And then you can scroll to the bottom to check your answer for all the bonus ones. Okay, so going back to question number 1, talking about arc length. So we're trying to find the length of this arc. We're trying to find this arc length for this circle. So I'm going to highlight. So they have the central angle as 340 degrees. I know this picture looks kind of weird, but we're going, remember, full circle rotation is 360, so it's almost in the entire circle, 340. So let me just draw that out here too. So it had that arrow there too, that little circle. We're going this way, all the way around. All of this is what we're looking at for 340 degrees. That central angle. What else do they tell us? They tell us the radius is 3. I'm going to outline that because it's not super visible. And our goal is to find the length of the arc. So I'm going to highlight the arc as well. Okay. So when we're finding the arc length, we're thinking back to what we learned in class with our Engagely notes. You could check your notes. I'm reading off of my notes. I'll plug it in for us. So from our notes, we had our formula was the arc length divided by the circumference. Circumference is equal to the central angle central angle divided by 360 degrees, which is our total. So again, it's kind of like it's the distance. It's our ratio for distance, and then the ratio for the angles. So ratio with distance, ratio with angles. So arc length, that's what we highlighted. That's our unknown. We're going to try to find that value. So I'm going to label it as x. We don't know it yet. We're going to find it. The circumference is talking about the distance. This is the grand total distance of the entire circle. Remember, circumference is almost like saying the perimeter of a circle. So we're going to find that total distance, excuse me. The central angle we highlighted as 340 degrees, that was given. And then our total is 360 for a full degree of a circle. All right, we're going to start just plugging this in. So starting with our first ratio, arc length, we don't know what that is, so we're going to label it as x. Divided by the circumference, we'll need to do some side work to find circumference. Circumference is going to be, remember, 2 pi r. So 2 times pi times r. We have to think of what r means, right? We're like, what is r? Remember, r is our radius, and we did identify that as 3. So 2 pi 3, 2 times 3 is 6. We'll leave it in terms of pi for right now. It also says leave answer in terms of pi. I wrote over top of it, but there you go. We don't have to simplify further unless you really want to. X divided by 6 pi, that's the circumference, is equal to the angle, the central angle. I don't know why I highlighted that wrong. Central angle, which was 340 degrees, divided by the total degrees, 360. Now that we've got these two ratios that are set up to be equal, this is a proportion that we're solving, we're going to need to cross multiply. So 360x is equal to 6 pi times 340. And again, we are going to leave this in terms of pi. So let's see, 340 times 6 is going to be 2040 pi is equal to 360x. Again, our goal is to get x by itself, so we're going to divide both sides by 360. Those will cancel, and let's see what that is in the calculator. 2040 divided by 300 and... Where's the back face? There we go, 360. So again, this is in terms of pi. So this was, this is the coefficient, and then pi. So x would equal about 5.7 pi, or if they were asking us, right, what is that exactly? 17.8, and we were finding arc length, but they didn't give us any units, so we'll just leave it as that. There we go, and that's it. Arc length. Usually they'll say like radius is 3 inches or something. So this is arc length is again another distance, like circumference would be a distance. So it's unusual that in this example there's no units. So be careful if on your exam there are units. Make sure you're including the units, right? If we're solving for an angle, it needs to be degrees. If we're solving for one of the distances, it would need to be whatever it is, inches, centimeters, whatever those units are. Okay, so that was the first one. Going to slide 6, this is a bonus question. If you're feeling confident, you can skip the bonus questions. These are just in case you would like some more practice. You can try this on your own. And then again, try working it out in this space, just like we do in class. We do it together, and then you try on your own. But if you're feeling confident, you can skip all the bonus ones. That's okay. So you can scroll down to the bottom, and you can check your answer for all the bonus ones. All right, moving into 2.2, volume and surface area of cylinders and cones. Question number 2A. Let's see what is going on here. So it says, need help with this problem? The video explanation. This is the video that you're watching. Question number 2A, volume of a cylinder. The question is, how much salsa is missing from the jar? How much salsa is missing from the jar? All right, so we are noticing, right, our title is also volume of a cylinder. This is a jar which looks like a cylinder too. Okay, so let's see here. We are focusing on volume. We want to know how much salsa is missing. We can see the height of how much salsa we have and the total, right? So really, we're just trying to find like this volume here of this empty space. Does that make sense? Empty space volume. Because we want to know what is missing. How much is missing from the jar. All right, so again, our volume for a cylinder is base times height, just like any volume, except the base for a cylinder is a circle, so it's pi r squared times the height. So a couple ways we can do this. We could find the total volume, and we could find the volume of the salsa and subtract it to find that missing volume. Or because we're right, might be a little bit easier, we could just calculate this new height and just write our own equation for that. 10 minus 4 is going to be 6 centimeters, so that's the height of what is missing. And we do have the radius up here. 5 centimeters is r, so we've got our height, we've got our radius. We're just going to plug it in. Volume is equal to pi times the radius 5 squared times our height, which is again the missing salsa where it's empty. That is a height of 6. We're going to use our calculator. Maybe, if it will let me. So 5 squared is 25 times 6 is going to be 150 pi. And let's see what that is. 150 pi. Rounding to, usually for our class, to the nearest 10th place or 100th. So if it's 100th, it would be 0.24. If it's the 10th place, 0.2. So we're going to say this is volume is equal to 471.2, and the units again. So volume is when our units are cubed. So this is going to be centimeters cubed. And then we'll box. All right, so again, different ways we could approach this. We could have found the total volume and subtracted it by what was given with the salsa to find this missing amount, or making our lives a little easier. Okay, let's just subtract the height since those are given and just do one volume equation. All right, so that's volume of a cylinder. All right. Here is a bonus question of number 2, finding the surface area of a cylinder. And then again, if you scroll to the bottom, you'll be able to check your answer, see if you got it right. So question number 2 is going to look like something like this. It's either going to be covering volume of a cylinder, it might cover surface area of a cylinder, or question number 2 on your exam might even cover surface area of a cone. So we're going to go ahead and go over this one. Surface area of a cone. So a roof is shaped like a cone. It's looking fancy. It's like a little castle. That'd be really cool if that was like your room, like at your house, where you live. That would be really cool. I would like that. Anywho, like that'd be really cool looking up. Anyways, roof is shaped like a cone with a diameter of 12 feet. They don't have that in the figure, so I'm gonna just add that to information for us. Okay, I'm gonna draw to the best of my ability a circle, and they're telling us the diameter of the base is 12 feet. Diameter. This is the diameter. One bundle of shingles covers 32 square feet. How many bundles should you buy to cover the roof? Okay, so we're given some information about this cone, and we're also told a little ratio here, so a little bit of extra information. They're telling us about the cone, right? A little bit of extra stuff. Let's see what's happening. So they're telling us that the shingles, one bundle covers 32 square feet. We need to find how many shingles to purchase. So this is going to be 2 parts. So I'm going to say part 1, just like planning ahead. Part 1, we need to know how many square feet is this roof. Need to know square feet of roof. We need to know that amount. Then part 2, we're going to use that use that number to find bundles amount of shingles. Maybe that makes more sense. To find amount of shingles. Amount of shingles. All right, so we're going to jump to our notes here. I'm going to find where we talked about surface area for a cone. Here it is. So from our engagement notes, we had two different formulas for surface area. We had the total surface area, so that's including the cone and the bottom, like every surface of the cone. And then we also had lateral area, which was just like the outside piece of the cone, where we're not including that bottom piece. So we need to think, which one do we need, surface area or lateral area for this one? Well, it's a recording, so I don't know what you're thinking, but we probably would not need roofing inside the house, right? Roofing is outside. So because it's a roof, this is going to be talking about lateral area. We're just looking at the lateral area of this cone. So the lateral area, this is from our engagement notes, is pi RL. Pi times the radius times the, it says L, it's supposed to mean like slant height. And they do give us that slant height of 13 feet. We're not given the radius, we're given the diameter, but we know that the radius is just half of that. So radius is equal to 6. And then we'll go ahead and plug that in. Equals pi times 6 slant height. We cannot speak. 13. Calculator. 6 times 13. We do want a specific number, so times pi. So the lateral area, again, that's just the outside of the cone. We're not including the bottom circle piece because we don't need to put roofing inside our house, just in the outside. Lateral area is going to be 245. Yeah, 245. This is square feet. Square feet. Remember, for area, units are always squared. Volume is cubed. So now we know the total area of this roof. Now using this, we'd like to know how many shingle bundles we need to purchase. And one bundle is going to cover 32 square feet. So how to know how many bundles? We're going to take that amount. This is our total square footage. Divide by 32 to see how many bundles of shingles we need to purchase. So 245 divided by 32. So we'd need, right, we can't buy 0.6 of a bundle. Even if it was like 7.1, because we're purchasing like an item, right? Could you imagine like you do the shingles and then because you forgot that 0.1 amount, there's like a gap on your roof, right? When we're doing something like this where we're purchasing for like a project, we're rounding up to the whole number. So this is going to be, we would need 8 bundles. 8 bundles of shingles. That's all we know. We don't know the cost of the bundles. Who knows? But we will need 8 containers of shingles. Seems like that wasn't very much. I feel like it was going to be a lot more. But there we go. That's how we do it. 8 bundles of shingles. Question number 2. So again, for question number 2 on your exam, it might have volume of a cylinder. You might see surface area of a cylinder. You might see maybe surface area of a cone or even volume of a cone. And for this one, for part B, volume of a cone, you're going to scroll to the bottom and you can reference a sample on how we calculated this. This one is working a little bit in reverse. We're given a cone. We're given the diameter, volume, we need to find the height. So we're working a little bit backwards, but still using those same formulas. All right, 2.3, now we're looking at volume and surface area of spheres and hemispheres. So question number 3, let's dive in. Let me get to my notes. Oh, it's like, why isn't this working? All right, surface area of a sphere. So surface area, I gotta find surface area. Here we go. Here is my formula from my Engagely notes, right? Because if this was the exam, it's open Engagely notes. We're constantly checking, referencing our notes. Got our split screen situation so we can cross-reference all the time. So surface area of a sphere, the formula is 4 pi r squared for surface area. Okay, so find the surface area of this sphere. And yet again, oh my goodness, they keep giving us the diameter. We're like, dude, we don't want the diameter. We would like the radius, please. If you could, that would be so nice. But it's fine, because we know what to do. We're going to take this diameter, 18.3. I'm going to divide it by 2. So that way I can know what is the radius. The radius is 9.15. Why is that looking crazy? Let me redo that. That was looking kind of ugly. Radius is 9.15 meters. Let me just double check. Yeah, 9.15. Okay, cool. So now we know what the radius is. We're just plugging it in, like for the whole, again, this pretty much entire unit, we're just plugging into our formulas. So surface area is going to equal 4 times pi times the radius, which is 9.15, and we're going to square it. So let's check in the calculator. 9.15 squared is going to be that amount, all right? And we're going to multiply that by 4 and also by pi. And we will get the surface area is equal to 1052.1, rounding to the nearest 10th place. Again, it didn't tell us where to round to, so I'm just going to say the 10th. And this is units squared, so meters squared. Again, surface area, units are always squared, always squared. So surface area of a sphere, when we're given the diameter, right, to do that little extra step there, finding the radius, hint, hint, okay? Bonus on 14, try this one on your own. This is finding the surface area for a hemisphere. Answer is at the bottom, so you can check your work. Last topic in Unit 2 is volume and surface area for prisms and pyramids. You might have noticed on the last one we skipped volume. That's because you won't be seeing it on your exam. So I'm helping you guys out, cutting down some of the questions. All right, so looking at question number 4, we're going to find the volume of a pyramid. Volume of a pyramid, and I got to get my notes. All right, volume of a pyramid. Let me write it out. Again, I'm just checking. I'm referencing my Engagely notes. I've got my slide. I'm going to update. So volume formula, just like in our exam too, you guys are graded again on showing your work. So we want to make sure we're showing every single step. We're rewriting those formulas, making it super clear where we're getting our answers from. So volume is 1/3 the base times the height. Again, it's 1/3, similar to how with a cylinder and a cone. Remember, a cone is 1/3 the volume of a cylinder. For a rectangular prism, this is some of my best work of drawing here. Wow. You can definitely tell it's a rectangle. From a rectangular prism versus a pyramid, very similarly, it is also 1/3, 1/3. So pretty cool. That's where this formula comes from. It's 1/3 of a rectangular prism. So 1/3 of the base, let's color code. You know what? Why not? So the base is here at the bottom. That is the base times our height of the pyramid, which is given, and we're just plugging it in. So volume is 1/3 the base. Is that a 1? Let me just erase a little bit. Yeah, it's a 1. Base is 2 times 1, right? The area of the base, length times width, base times height, 2 times 1, times the height of the pyramid, which is 2. All right, we're going to plug that all in a calculator. It'll let me. 1/3 times 2 times 1, which doesn't change anything, times another 2. Oh my goodness, this is a very, very small pyramid. The volume would be 1.3 cubic feet. So again, we're just using that formula to find volume. This is a very, very small pyramid, very small, but sometimes, that happens. Sometimes volume isn't a very large number. And it's okay. We did our work correct, right? We're checking, yep, base times height for the area of the base times the area of the height. Yep, 2 times 2 times 1, a third of that. Yep. All right, so that's question number 4 on your exam. Is going to look very similar to this. There's a bonus question number 4, finding the volume of a prism. So you can try that on your own and scroll to the bottom. The answer key is missing, so I will investigate that. It should be there. I will come back to that. It will be there when you get there. Here we go. Last question that we're going to cover in this video is question number 5, what you will see on your exam. Question number 5 is going to be a little bit of a complex problem that has to do with volume. In this example, we've got a container with, apparently, according to this description, that, in case you didn't know, is macaroni and cheese. That does not look like macaroni and cheese to me. I don't know if I would be interested in eating that. It looks like something that maybe I might make because I'm not a very good cook. But yeah, that doesn't look food safe. That does not look safe. But we're going to estimate the amount of macaroni and cheese that's left in the casserole dish. We're giving an estimate. So remember, estimate, it's an approximation. And then for part B, we're going to see if the remaining macaroni and cheese will fit in this container. So we're going to need that volume to then check, will it fit in this volume? So we're going to use A to then answer part B. So kind of making a plan of attack again. All right, so estimate the amount of macaroni and cheese. Okay, so this is kind of like a composite figure, if you will. I'm going to give us a very rough drawing here of this quote unquote macaroni and cheese. I, again, do not think that that's what that is, but I'm not the one that cooked it. So sure, whatever you say, macaroni and cheese. Okay, so it looks like this. We took, right there, you can see there's a big chunk missing. Someone ate, almost looks like about, it's an estimate. It's an estimate, guys. We'll say it's about a fourth. Do you guys agree, right? If we cut that into 4 slices, we're missing 1/4. Yeah, let's go easy on ourselves. Let's not make this too crazy. 1/4 of the total. Why don't we just, instead of breaking up, finding the volume of this rectangle and that little square, what if we just find the total and then divide it by 4 and then subtract that, or multiply it by 3/4 to find what 3/4 of it is? Again, the big idea here is we're making an estimate. We're giving an approximation. It's not going to be exact because we're estimating. Or we're not going to go in and count up how many macaronis are there. Again, this is very questionable macaroni and cheese. I can't get over the fact that how strange this looks for macaroni and cheese. There's definitely something else in there, because why is it brown? Unless it burned, maybe? Anyhow, we're missing a 4th is the bottom line. So we've got our plan. We're going to find the total, subtract a 4th from that to figure out what's the volume left over. All right, lucky for us, volume for a rectangular prism is pretty easy. The volume from our notes is length times width times height. So the length is 12, the width is also 12, and the height of the casserole dish is 3. All right, so 12 times 12 times 3, we'll get the volume is about 432 cubic inches. This is the total casserole. But again, we just need 2/4 of it, or we could take a 4th and subtract. I'm going to just do 2/4. So 432 times 2, oh my gosh, 3/4. What am I doing? 3/4. So again, because we've got 3/4 left over. So the volume is going to be 324 cubic inches that's left over. So this is answering for part A. This is estimating how much is left over. Again, we're like, okay, it's about a 4th missing, so 3/4 is remaining. Now we're going to check, will this fit in this storage container? And we have to explain our reasoning. So it might be helpful if we knew the volume of that storage container so we could compare volumes. So second volume Again, length times width times height. 7 times 7 times 4. 7 times 7 times 4. So the volume of our storage container is 196 cubic inches. Will that fit? Looks like we have way more macaroni and cheese than our storage container. That's so sad. We have to throw it away. Wow, that's a real bummer. I know we're devastated about that. So we would say, oh no, right? Maybe that's like a hack if you have like for family members that maybe aren't the best cooks. I'm sure like my own son would do that when he gets older. Like, oh man, I'm so sorry, Mom. I brought just a tiny little container. Like it won't fit your food. I'm so sorry. Like I just gotta, I just can't take anything. So explaining our reasoning for part B. So part B, no, the mac and cheese will not fit in the container because there is too much mac and cheese. Container is too small. It will not fit. There we go. And that's how we would do this problem if we saw something similar. So just go slow, read through what's happening, what's going on, what are they trying to tell us here, what are we trying to do, making that plan of attack. All right. I think there's a part 2. Yep, there is a bonus one, and I have the answer key at the bottom for you to check. Another one with complex volume with like volume of composite shapes. All right. This is the end of this video. That is the end. We've got nothing else. For your extra credit for this quiz, it will be something to do with math. That's all I'm going to say. Extra credit. All right. That's it. Have a great day. If you have any other questions, you're not sure about something, again, please let me know. Let me know, Canvas inbox. And that's it. Bye, guys. Take care.